Well, you should first start by reading the question properly and understand what the question is asking you to calculate for. So if you want to find the value of k, and if you recall that the sum of probability of a particular distribution is 1, then everything becomes very simple. As the sum of probability is 1, so we just add up all this, so written here, equate this to 1, you should get the value of k equal to 0.1. Now, next up is this question here. In fact, these two questions here, the part B and C, we look at them together, and probably whereas between 3 and 6 inclusive of 6, and when s is odd. So really 3, 6, but not including 3. So really talking about 4, 5, and 6, so we just add these 3 together. And the next one is when this is odd, s is odd. If you return to here, odd means we're talking about when 3, 5, 7, and 9. Okay. So that means again the property, sum of property of s equals to 4, 5, 6, sum this up, and it's 0.5 because k is 0.1. So you actually see this 3, 5, 7, 9, and that means you're calculating the k, and this is 2k. S equals to 7 property is 2k and k, and because k is 0.1, you get 0.6. So next up is this one right here, and this is a problem on binomial. You should read the question first. And about the assumptions, I would suggest that you go to page 287 of a textbook, and there you can find out more about the assumptions. But I will write your assumptions here for your benefit. There are 3 or 4 ideas, 3 ideas. You might say one of them would be each delivery is independent. The other one is about the idea of 2 outcomes of binomial. So in this case, the delivery either makes it or in 30 minutes or it does not. And the probability of the delivery makes it within 30 minutes is the same for every delivery. And next up, the second part, the part B. Look at the part B1, B2 together. Here they say 10 orders are delivered. Well, it means that 10 successes exactly. Whereas here would mean that more than 8, so 9, 10 more successes. In other words, we are talking about this probability and this probability. And I will work with part 2 first, because this is equivalent to 1 minus the probability of x less or equal to 8. And using technology, you should be able to show that this is approximately 7, 8, 6. And as for this one, the one right here would be 0.349. 3 significant figures would be enough. And then finally, I'll look at part C and part C1, 2 together, and also because there's the word hence here, and here they ask you to calculate mean and standard deviations. So in other words, it's implying that you should use normal approximation here, and therefore you will end up getting these 2 values. And then to do this, the part 2, the random variable will be distributed normally with 360 mean, of course, and 6 square, the square of the standard deviations. And here it means at least 370, so it means this is a case, and we need to do a correction here. So it would be p, a new variable, let's call it x star, greater or equal to 369.5. We usually correct it down 1 unit because we might recall that we need to include the number 370, so we move it half a unit down. Or half a unit less, that is. And the outcome should be roughly 0.0567, correct to 3 significant figures. For this particular case here, if you read this carefully, you realize that this is really hypothesis testing of proportion, and you can go to page 298 of a main textbook. We can read through until about 301 and so on to get more ideas and understand further about the ideal hypothesis testing of proportion. And also you should take a look at page 305 on choosing the right sample size. Anyway, this is the formula, and because of this 0.14, it comes from the 7% the width of confidence interval, so 7% times 2, so 14% here, 0.28 from the 28%, and this is 1 minus p. So you get 158, or roughly 0.5. Of course, we take the larger integer, so 159, and that will be it. As for stating the null hypothesis and the alternative hypothesis, shouldn't be a problem for we want to show that there is in fact a change, but you are innocent until proven guilty, that idea that. So we'll try to reject this, and so the proportion null hypothesis will be there's no change, and the alternative will be there is indeed a change. Of course, null distribution of the test statistics clearly is a standard normal, so 0 and 1 square for the 0 mean, and then a standard deviation of 1, and then to calculate the test statistics, or the z-score, we employ this formula actually in page 299, I think. And actually, if you read through the questions, the p cap estimate would be 69 over 200, so that would be 0.345, and of course the p naught is 28%, or 0.28 given earlier, and the sigma is this, your p naught, 1 minus p naught, that means 28%, okay, and that would be roughly be well, anyway, we can keep this value. So just substitute all this into here, and you will get this this value, roughly 2.047. And so to graph this, we can show the region like this, and the rejection region will be this too. And well, whether we should reject the null hypothesis is very clear right now. The reason is, this test statistic 2.047 is really greater than 1.96, so we can reject H null. And then how should we interpret this result when we reject H null? Basically, when you reject H null, we suspect that then there is a change in the percentage of visitor, and we just say the percentage of visitor to the Greenland National Park who are less than 30 years old, well, it could be more than 28% at present, and so that's it. So if you read these questions carefully, and you will be able to identify all the key values, I will write them down right here. So these are the key informations, and this is really about the confidence interval for means, 95% confidence interval. I think you can go to page 267 of the main text, and if you employ the formula, this is the outcome. So here it is, and what's the interpretation of our answer here? Well, so this is interpretation of this particular result, and key values parameter are here, and so you will get this outcome, and this is your interpretation. And then next, read through this and use information part A, and here is it, asked less than 24 marks. So use the graphics calculator, input this. Here again you can key in any very negative value, that will be okay, and you will get 0.0978 up to 3 significant figure. And now for us to handle this particular part of the problem is that how do we then justify our answer later? First, we start with the confidence interval we calculated in part B 31 and 35. So what we will want to do is that if we can show that these two bounds, probability is actually less than 22%, then that will be safe, right? So this is what we want to do. We take the lower bound, the lowest mean the leftmost bound, and then calculate that the probability that the students will score less than 24 is this one, and then for the rightmost bound, you calculate probability that we did. So the probability of them failing, being scoring less than 24, both of them will be actually less than 22%. So in other words, we may say that since both values less than 22% or 0.22, the teacher's claim is quite fair. And finally, how do we justify this claim here? And so what we do is we calculate the maximum percentage of fail from when math is being taught in Bahasa, Malaysia. And so in part C1, we actually calculated the percentage of fail when being taught in Bahasa. That is X24, and that was I think 0.0978. It translates to roughly 9.78% of fails. So this is the maximum fail rate. Okay, but now let's look at if it's being taught in English, what's the minimum fail rate? So we compare the maximum and minimum if there's a main difference. So for that, we'll be looking at part 2. That be here, like C2. We calculated that the percentage, she's right here, it's 2. So the minimum fail rate is 10.6, 0.106. So for the minimum fail rate, X and 24 is 0.106. That means this is a 10.6%. So if you think about it, this is if being taught in Bahasa, this is a maximum fail rate. But if being taught in English, this is a minimum fail rate. So in other words, we can then compare that since 10.6 is greater than 9.78. So the claim made by the educator is justified. So you just make the conclusion, then that's it.